Hello and welcome to After School. The subject is chemistry and the topic is basic calculations in O-level chemistry. I want to let viewers know that for you to do proper calculations in chemistry and also arrive at correct answers, there are basic things a student must know. The first is a good knowledge of the periodic table to enable you know the positions, groups, and periods of elements, and thereby be able to predict their properties or characteristics. The second thing is the mass number, and the third is the atomic number. All of these are important if a student must do well when it comes to calculations in chemistry. Summarily, I've mentioned the importance of symbols, the combination of elements to form compounds or molecules, such that if we have to do calculations based on all of this, we'll be able to use their mass number or atomic number, depending on what is expected of us to calculate. As we go further, I'm going to highlight on the relevant calculations as it relates to mass number and atomic number. The mass number is used for calculations involving masses, while the atomic number is used for calculations involving configuration. Generally, elements are represented as shown on the board. If an element is X, Z is the atomic number, while A is the mass number. In other words, when we decide to represent an element like carbon, we are going to have 12 as the mass number on top. Then the symbol of the element, carbon, C, and then 6 as the atomic number below. We use these for calculations where we have to write configurations. For instance, from carbon here, 12,6, from the atomic number we can write the configuration to be 2,4, whereby we can predict that carbon is in group 4 of the periodic table. The same way we are going to use 12 when the calculation involves masses. Going further, we are going to take typical examples that will help us understand more of this. I tagged these basic calculations because they are basic. If you don't know this, you will find it difficult to do other calculations in chemistry. This is the basics. I said O level. From here you can now go further and do other bigger calculations. But they are important. You can do without them. The atomic number, like I have said, is the number of protons in the nucleus of an atom. And chemistry teaches us that in a neutral atom, the number of electrons are usually equal to the number of protons. Therefore, we can also say that the atomic number is the number of electrons or protons in a neutral atom. And from there, since it also tells us the number of electrons, we can write a configuration from where we can understand how these electrons are distributed in the shells. For example, we have carbon here, 2,4. It means that if this is a carbon atom, this is the first shell, and the second shell is the one on top, having 4 electrons out and 2 electrons in the inner shell. The reason carbon is in group 4. This has to do with configuration. Now, the mass number is defined as the number of protons and neutrons in the nucleus of an atom. The reason it is called mass number, because it has to do with the mass of that element. We already know from our knowledge on the subparticles of an atom that the neutrons contribute basically to the mass of an atom, or in other words, the physical properties of an atom, while the electrons are responsible for the chemical properties. So when we talk about mass number, we are looking at the number of protons and neutrons in the nucleus of that particular atom. The reason when calculations involve mass in chemistry, we will now use the number on top. We labeled A, the bigger number on top. That is the mass number. We are going to take few examples, because when you talk about calculations involving mass number, we are going to look at a lot of things. Number one, we are going to look at calculations involving number of moles. Two, we look at calculating mass of reacting substances. Three, we look at calculating molar masses or relative molecular mass, and so on and so forth. Let's get straight to the examples. The first example is, how many moles of magnesium are present in 12 grams? How many moles of magnesium are present in 12 grams? The formula for calculation of number of moles is reacting mass, or you can simply say mass, or mass given. The mass, the reacting mass, or the mass stated in the problem, all over molar mass. Now we move on. Magnesium, Mg, has relative molecular mass of 24. So if we are to calculate the number of moles of magnesium as stated in this question, we are going to say N, or number of moles, is equal to reacting mass, which we have been given in this question to be 12 grams. So we are going to say 12 all over 24, and that will give us 0.5. So we have 0.5 mole in 12 grams of magnesium. I urge viewers and students in general not to think of cramming the relative atomic masses or molar mass. They are either calculated or you get them from the periodic table, because they are constants, they can't change. Over years I finished school, I've never seen any change. They still remain the same. So in questions, they are usually given in block bracket like I have done below, Mg 24. Let us also take a second example that will help us further. But in this case, we are now going to calculate mass. The question says, what is the mass of potassium what is the mass of potassium in 2 moles of the element? What is the mass of potassium in 2 moles of the element? Potassium is K. The symbol is K. The relative molecular mass is, the relative atomic mass rather, is 39. So going by our formula, number of moles equal to reacting mass all over molar mass, the question wants us to find the mass. In other words, we are going to say number of moles. Okay, pause. Let me see. And you can. Okay. Yes, it's a pity I had to put something straight. Taking that question again, the question wants you to calculate the mass of potassium in 2 moles of the element. The mass of potassium in 2 moles of the element. I've already said it here that potassium has a relative atomic mass of 39, which I've written in block brackets. So going by the equation, number of moles from this question is 2, because the question asks for the mass of potassium in 2 moles of the element. So the number of moles will be 2, equal to reacting mass. That is what we are going to find. We will just write it as mass, or M, all over molar mass, which is this 39. So if we make mass the subject of the formula, we are going to have 2 times 39. So the mass of potassium in 2 moles of the element is actually 78 grams. 78 grams as shown in the solution here. So we have seen how the mass number can be used to calculate the number of moles and also the reacting mass. Again, we are going to look at calculation of molar masses. I would want to help my viewers here understand something that is very important. The relative atomic mass or relative molecular mass doesn't have any unit. Like we have here, potassium 39, magnesium 24, nothing is attached to it. But when you say grams attached, we now call it molar mass, meaning we are looking at the mass of 1 mole. What is the mass of 1 mole? In that case, we attach grams to it to show that we are talking about molar mass. Note this difference. The relative atomic mass doesn't have any unit. So moving on, the molar mass or relative molecular mass of compounds. Now we are looking at compounds. I started by saying that knowledge of the symbol of elements is important, because it is through this knowledge and the laws of chemical combination like reciprocal proportion, multiple proportion and all that, constant composition. From these laws, they guide us to understand how elements combine to form molecules and compounds. So if we are calculating the molar mass of a single atom like potassium, we will say it is 39 grams, because the relative atomic mass expressed in grams gives us the molar mass. But when a compound or a molecule is involved, we already know that in compounds or molecules we have more than 1 atom. We are now going to add the individual relative atomic masses of all the atoms that make up that compound. You will understand it better from the examples below. Just note this. To calculate the molar mass of a compound or molecule, you are going to add the individual, you are going to sum up the individual relative atomic masses or molar masses of all the elements involved in that compound or molecule, as written in its proper formula, correct formula. Alright, moving on. The first compound we are going to look at is sodium trioxocarbonate 4, Na2CO3. To calculate, we are going to calculate both the relative molecular mass and the molar mass. How do we do this? Sodium is 23. We will say 23 times 2, because there are 2 atoms of sodium in this compound. The reason I made mention of correctly written formula. We have 2 atoms of sodium in sodium trioxocarbonate 4. So as we calculate, we say sodium is 23, its relative atomic mass. 23 times 2, that will give us what? 46. For carbon, we only have 1 atom of carbon, and carbon is 12, as you have it up here. we'll say 12 times 1, and that gives us 12. Oxygen is O3. Oxygen is 16. Its relative atomic mass is 16. So since we have 3 atoms of oxygen, we are going to say 16 times 3. That gives us 48. When we add all of this, we are going to have something in the neighborhood of 106. 106. This is the relative molecular mass of sodium trioxocarbonate 4. While the mass of 1 mole or molar mass is 106 grams. This is what I was explaining a while ago. The relative molecular mass doesn't have units, while the mass of 1 mole or the molar mass of any compound, we have its units expressed in grams, which we know is the unit of mass. That is the first compound. The next compound we shall look at is magnesium chloride. Magnesium chloride. After this, I'll give you 2 examples that you will work on your own as assignment, which I will provide their solutions in the next video. The next compound I said is magnesium chloride, written as MgCl2. If you understand or you understood the last topic I treated, which was chemical combination, you will be able to explain why you have 2 atoms of chlorine in this formula. I'm emphasizing on formula, I've been saying it. For you to get these calculations right, the formula, if compounds are involved, must be written correctly to help you do your calculations. So we have 2 atoms of chlorine here because chlorine is in group 7. Chlorine is a halogen, requiring just 1 electron to fill its outer shell. So now magnesium is in group 2, having 2 electrons in its outer shell. Magnesium, the metal, will release electrons, which will be accepted by the non-metal chlorine. So since chlorine needs only 1, and magnesium is releasing 2 of its outer electrons, 1 chlorine cannot take the 2 electrons. The reason we now have 2 atoms of chlorine. 1 will take 1 to make up 8 electrons in its outer shell. The second chlorine atom will also take the next electron to make it up, because magnesium, being in group 2, will give out 2 electrons. So going by that, the formula is MgCl2. We have magnesium having 24 as its relative atomic mass, and chlorine having 35.5. If you have studied isotopes, you will understand why certain relative atomic masses will appear as decimals. So chlorine is 35.5. If I'm to calculate the relative molecular mass of magnesium chloride and the mass of 1 mole of magnesium chloride, here I will go. Magnesium is 24 and I only have 1 magnesium here. I will write 24. Chlorine is 35.5 and I have 2. So what I will do is 35.5 times 2. This will give me 24 plus 71. Therefore, the relative molecular mass of magnesium chloride is 95, while the mass of 1 mole is 95 grams. 95 grams. I hope you will understand it, my viewers. Magnesium 24, having only 1 atom, we'll put it here. Chlorine 35.5 for 1 atom. And since there are 2, we are going to multiply by 2. That gives us 71. The relative atomic mass, which goes without a symbol, will be 95. While the mass of 1 mole, which is either the relative atomic mass of an element or the relative molecular mass of a compound expressed in grams will now be 95 what? Grams. That is it. I will give you two examples to solve at home. The two examples has to do with aluminum hydroxide and ammonium tetroxosulfate 6. I will write out squeeze their formula in here so that it will guide you. The formula are very important if your calculations must be correct. This is aluminum hydroxide, aluminum hydroxide. Calculate the relative atomic mass and the mass of 1 mole of it. The next compound you will calculate is ammonium tetroxosulfate 6, written like this. The ammonium is enclosed in bracket NH4 with 2 written as subscript and then SO4. I'm looking at time to explain, that's why I'm talking about these basic calculations. I'm looking at when there will be time to explain why we have things like this when we write formula. It has to do with valency and all of that. This 3 here is actually the valency combining power of aluminium. But when we write formula, it is switched. You can say that for the hydroxide, which is 1, is for aluminium and is not written. Why the 3 for aluminium is written here? The same applies in this second example. The tetroxosulfate 6 is a radical with 2. And its 2 is now what is written for ammonium. And ammonium, which is 1, has nothing and it has been written for SO4. Remember, we don't write 1. So that will be a further lesson. But the assignment now, calculate the relative molecular masses and then molar masses of these elements, or of these compounds rather. The first is aluminum hydroxide and the second is ammonium tetroxosulfate 6. That is where we'll call it a wrap for today. I'll provide solutions to these 2 assignments when next we meet. Thank you.